All right, let's continue with another video for lesson 16 about normal distributions, specifically applications type problems. In this video, we're going to be talking about how to find the area given some data values. And remember that the area between 2 points on the normal curve is also the probability that a random value is between those 2 points. So let's get into this example. So we have the XYZ company who makes car batteries. And suppose after years of product testing, they know the average lifespan of a battery is normally distributed, a bell curve, with a mean of 59 months, a standard deviation of 6 months. This is sort of realistic data. The company guarantees that the battery lasts 48 months with some kind of money back guarantee, let's say. What percentage of batteries fail before the 48-month guarantee period is up? So in summary, we could condense all of these words down to some math symbols. It's saying it's normal, the mean is 59 months, the standard deviation is 6 months, and we're trying to find the probability that X is going to represent a randomly selected battery. The lifespan of it is less than 48. So there's two approaches to solving these problems. Both approaches have pros and cons. Let's get into the calculator approach. So this is what we're solving, and what I would strongly recommend you do for these is draw a picture, either calculator approach or the z-table approach that we're going to see in a second. Either way, drawing a picture should help. So it's a normal curve, it told us that, and we're going to label 59 here in the center, and we're going to label the thing we're testing. Where's 48 on this number line right here? 48 is somewhere over to the left. It doesn't really matter exactly where you put it. We're just put 48 somewhere to the left. And the thing we're trying to find is what percent of batteries fail before, that's a less than, 48 months. So we draw our line at the point of interest, and the probability we're finding is the area left of this point, so we shaded it blue here. And with a calculator, it's pretty easy once you get this far. We're just going to use the normal CDF, normal cumulative density function, which is just a fancy way of saying we're adding up all of the area between whatever left point and right point you put in. And for the left point, we're putting in negative infinity, which does not exist on the calculator, so we're using just gigantic negative number in its place. And for the right point, we're putting 48. So left is negative infinity, somewhere over there. Right point is 48. So this is calculating the area between those 2 points. And we give it the mean and the standard deviation. So instead of 0, 1, like when we do z-scores, we put the actual mean and the actual standard deviation of the data. And it gives an answer, 0.0334. What does this answer mean? This is a proportion out of 1, or if you convert it to a percent, it would be 3%. Now this is asking for percent, so 3% of batteries fail before the 48-month period. And you're actually done with that problem. The alternate approach is the z-table approach. It's not better or worse. It's a little more work, but it has a benefit of kind of tying into some of the later stuff a little bit better. But either way you want to go is fine. So in a z-table approach, the first step is converting the number of interests to a z-score. So we're going to take the 48, and that's our x. And how many z-scores is this value that we're interested in? Well, so we plug it into the z-score formula, we calculate, and we get negative 1.833. So comparing that with that, we're just figuring out what's the z-score for this value right here. So almost 2 standard deviations below. And then we would still draw the normal curve, but instead of the actual data values, we're just going to put z-scores, 3 to the left and 3 to the right. Put the z-score of interest that you just calculated on there, and we want to know the left side and we would look that up on a z-table. Oops, so negative 1.833 is here, so that's the area to the left of that z-score. Area to the left of this z-score, that's what we were trying to find. This is why you draw the picture, because sometimes you want the area to the right, or even the area to this in the center of 2 points. But this one's easy because we want area left, and this table gives area left. The area left is 0.0336, which is our answer as a proportion, and as a percent it would be 3.36%. So the z-table approach is similar. We just have to convert to z-scores, and then we do everything the same. This slide, I'm going to actually show the relationship of z-tables versus z-scores versus actual data. So the way we did the actual data, we put the actual mean there, we put our value of interest, and we shaded it in a direction that matches what we're trying to find. In z-score, and that was found with normal CDF. In terms of z-scores, the mean is always a z-score of 0 because it's 0 standard deviations from itself. And the value we're finding is, in this case, negative 1.8 standard deviations below. And we could actually put the z thing into normal CDF as well, in addition to a z-table. So the probability that the value is less than 48 works like this, and this z-score is just scaled. This last one is just scaled to z-scores. And we could do that in normal CDF as well and get the same answer, and the z-table as well and get the same answer. So whichever approach you like is fine. You're not going to be strictly held to one or the other. So we'll continue in another video